welcome, and I want us to look at this question that gave a number of candidates and learners a lot of difficulties, and it's quite pretty and simple question. That is question number 11. The figure below represents the curve of the function y is equals to 1 minus s sine wx for the range of negative 35 degrees less or equal to x less or equal to 50 degrees. So the range of value for x is between negative 35 degrees and positive 50 degrees. So the wave is actually drawn between those values. And of course, as much as we may have issues with the curve, and especially at negative 30 and negative 25, the curve ought not to have passed through those points. All the same, this is a national examination, and we don't want to dwell so much on the quality of questions that are being tested to students, and without casting aspersions on individuals who set this particular question. It is noted that the wave ought not to have passed through the points that is actually passing, and what came out is that the wave should have passed, somewhere between at the point 1, that is at negative 30 degrees. The wave should have passed at point 1. So I hope in future we wouldn't have such issues and problems, because a national examination should actually be error proof. So negative 30 degrees, the wave should have passed at 1 at this point, and also at negative 25 the wave should have passed at the mark 2 and this point. So of course we have to work with the wave the way it is, and therefore we do not really want to dwell on what may have happened to the proofreading or something like that. Now, the question required the candidates to determine the value of A and W. A is the amplitude of this wave, and again, this wave gave a lot of challenges to a number of candidates. They are not able to determine the amplitude correctly. Now, if you look at the displacement, the maximum displacement from the x-axis is actually 3 units. From this point to this point, you can see it is 3 units. Look at the minimum, or the displacement, the negative y-axis is actually from this point to this point. So that is from 0 to negative 1. So we can therefore say that the wave oscillates between negative 1 and positive 3. And for us to get the amplitude, we were to get the mean of that. And that is 3 minus 1, then divide by 2. And that should have given us the amplitude. So we can determine or calculate the amplitude as follows, that the amplitude will be equal to 3 minus 1, then divided by 2, and this is 4 divided by 2, which gives us 2 units. Now that gives us the value of A, which is the amplitude. Now to get the value of W, we expected to determine the wavelength. Now the wavelength is the point at which two particles are at the same point throughout the wave. Now check at this point. You can use this point, which is negative 15 degrees. Take a particle at this point. Now a similar point on the along the wave is actually at this point. Check the degrees is 45. So basically it's from negative 15 and 45 degrees. So to determine the angle between these two, we take 45 degrees minus 15 degrees, which gives us 60 degrees. So therefore, if we take W will be equal to 360 degrees divided by as 60. Now, why are we saying that 360 degrees divided by 60? Now, that is the period of this wave. And therefore, when this is simplified, our W becomes 6. And again, a number of learners or candidates were not able to determine the value of W correctly. And to determine the period, which is the value of W, if you look at the equation that we were given here, which is y is equals to 1 minus a sine of wx. Now, this value, which is the coefficient of, which is the w, which is the coefficient of x, gives us the period. That means 360 divided by w should give us the period. And already we have seen the period from the wavelength, which in our case was from this point to this point. In other words, from negative 15 to 45. So our candidate will have still used the same concept to get the sixth, that is 45 minus 15, you get 60. So 360 over W is equals to 60 degrees. And that will have given us W as 360 degrees divided by 60, and our W will still be 6. So those were the approaches that were expected for this particular question. And unfortunately, very few candidates were able to score this particular question. So as we teach these concepts, let us use the right approaches. Let us teach our learners and our students how to determine the period and also the amplitude from a given wave. Kindly remember to share and subscribe so that we can continue helping learners to be well prepared for their national examinations.